Hello everybody, thanks for tuning in. We're going to start with a review of the order of operations. We're going to take a look at the expression 5 plus 3 times 2, and we're going to evaluate this expression twice, doing the operations in a different order. So first, we're going to do the addition and then multiply and see what we get. So if we do 5 plus 3 first, 5 plus 3 is 8. And then if we multiply by 2, 8 times 2 is 16. Okay, now we're going to take a look at it in a different order. Let's see what happens if we multiply first. 3 times 6, and then 5 plus 6 is 11. So you see, when we did the same problem using operations in a different order, we got different answers. So one of these is correct, one of these is incorrect. Well, the problem we did first was incorrect. What we're supposed to do is multiply before we add. So we're going to review the order of operations, and then we're going to do some practice problems. It would be a good idea to copy down these order of operations. We're going to refer to these thought processes as the problems in class. I know some people have learned shortcut, PEMDAS, or please sailor. I'll tell you in class why we avoid using that and why we're just going to think of these 4 steps that we're going to get familiar with. You can see part C, they asked if we got the same answer or different answers. Obviously, we got different answers. And in part D, we think that the order of operations is important because to calculate accurately, we need to perform operations in all the steps in the correct order. So feel free to pause the video, write these things down, and when you're ready, press play, and we'll continue. So now we're taking a look at example 2. We're going to try a couple of these problems. Each of these problems requires 2 steps. Let's try to make sure we do the correct order of operations. So let's see what happens here. At the first problem, we're looking at 5 minus 6 plus 4. So we look, and there's no grouping symbols. We can skip step 1. There are no exponents or radicals. We can skip step 2. There's no multiplying or dividing, so we can skip step 3. We're on to step 4, add and subtract from left to right. So we're going to have to do the subtraction first. And the second thing we'll do is the addition. So if we do 5 minus 6, that equals negative 1. If we do negative 1 plus 4, it equals positive 3. So the answer that we should get is positive 3. Moving on to part B, go through the order of operations. First step is do all the work inside of grouping symbols. You can see right here, we have an operation inside of the parentheses, so we'll do 9 plus 3. 9 plus 3 equals 12. The second thing we'll do is the multiplication. When there's a number written next to parentheses like this with no symbol in between, that's implied multiplication. So we'll do 5 times 12, and we'll get 60. So the answer that we should get is 60. Now keep in mind, the only reason we did addition before multiplying is because addition was inside the grouping symbols. Okay, let's take a look at part C. The first step in the order of operations is to look for anything in the grouping symbols, but there are no grouping symbols, so we'll go to step 2, perform all exponents or radicals. Well, we have an exponent here, 3 squared. Remember that 3 squared means 3 times 3. So 3 squared is 9. We're going to rewrite this as 10 plus 9 minus 9. Now we're down to all adding and subtracting. We're in step 4, so we'll go from left to right. 10 plus 9 is 19, and 19 minus 9 is 10. So the value we get for the expression in part C is 10. Okay, moving on to part D. We've got a bunch of steps here. Let's look for grouping symbols. There are no grouping symbols, so we'll go to step 2. We'll look for exponents and radicals. There are no exponents or radicals, so we'll go to step 3. We're going to do all the multiplying and dividing from left to right. Here's dividing, here's multiplying, so we're going to work from left to right. We'll do 20 divided by 4 first. And then we're going to take 5 times 2 to get 10. So to rewrite this now, we'll have 7. It's a positive 10, so we'll say plus 10, and then minus 10. Now we're done with multiplying and dividing. We'll add and subtract, going in order from left to right. So 7 plus 10 is 17, and 17 minus 10 is 10. So the value we get for part C is 10. If we go through the same thought process each time we evaluate an expression, we're likely to reduce the number of careless mistakes that we make, and we're likely to increase the number of accurate answers we get. Hopefully this makes sense. When you're ready, go on to the example 3, and you're going to try some problems on your own. Feel free to pause the video right now, work these out, and then when you're done working out your answers, press play and check your answers. Okay, the answers will show up in 5, 4, 3, 2, 1. Okay, so taking a look into part A, hopefully we ended up with a value of 2. One thing to keep in mind is that when you see this long fraction bar, this is actually a grouping symbol. This is like having implied parentheses around everything in the numerator and denominator. There's really no operation to perform it in the denominator, but we'd have to do the addition in the numerator first because they're implied grouping symbols around the 3 plus 7, and then we'd continue evaluating. A little trivia for you. This long bar has a name, and it's called a vinculum. It's used in radicals, and it's used in fractions. And a vinculum is a type of grouping symbol, just like parentheses and brackets and braces. So check the rest of the problems. Hopefully things are making sense. If they're not, then when you get back to school, feel free to ask questions, and we'll discuss the problems and clear things up. Now let's go to example 4 when you're ready. Okay, we're going to talk about substituting. Substituting means, just like it sounds, we're going to take something out and replace it with something else. Okay? If you look at the very top of the page here, it says evaluate the following. Evaluate this expression 4x squared when x is negative 3. So that means we're going to take out the x and we're going to replace x with negative 3. Since these things are equal to each other, we're going to take out one and replace it with the other. If you write it down like this without parentheses, you get 4 times negative 3 squared. And if you write it with parentheses, we get 4 times negative 3 squared. Now, that might not seem like a big deal to you, writing these things different ways, but I'm going to show you something. If we evaluate this without parentheses, we go 4 times negative 3 squared, we get an answer of negative 36. If we use parentheses, 4 times negative 3 squared, we get a value of positive 36. So there is a difference, and it's important to remember that whenever you substitute values in, especially negative numbers, we would absolutely want to use the parentheses. It's a good idea to use parentheses whenever substituting to increase your accuracy. Okay, so we'll go like this. 4 times negative 3 squared, order of operations. Do work inside of grouping symbols. Well, we have parentheses, but the number negative 3 is inside of there. There's no operation to do. There's no adding, subtracting, multiplying, or dividing. So we'll go to step 2, perform all the exponents. So think about it like this. Negative 3 squared means negative 3 times negative 3. Negative times negative is positive, and 3 times 3 is 9. So this becomes 4 times positive 9. And 4 times positive 9 is positive 36. So I'll tell you what, at this point, why don't you try number 4, try part A, and then stop. After you finish part A, play the video and check your answers. So go ahead and hit pause. The answer to part A will show up in 5, 4, 3, 2, 1. All right, hopefully your first step looks something like this. You can see in the problem, if you look at it, that the value for x is -6, which means everywhere we see the variable x, we're going to replace it with the number -6. And we've got to remember to use parentheses around numbers when substituting, especially when using negative numbers. And now we'll perform the order of operations. We'll look inside of grouping symbols, but there's no operations to perform inside the parentheses, so we'll look at exponents and radicals. There's some exponents right here. -6 squared is going to be -6 times -6, or positive 36. This becomes -8 times positive 36, and then -5 times -6. Okay. Now we'll do the multiplying from left to right. Okay. Step 3, perform all the multiplying and dividing from left to right. We don't have any dividing, but we have multiplying. Okay, so -8 times 36 is going to make -288. And be careful here, because we're looking at a -5 times a -6. And a negative times a negative makes positive. This will become positive 30 or plus 30. When you're adding and subtracting, well, let's try this without a calculator. We think it moves on a number line. A -288 would go to the left because negatives are on the left side of 0. A plus 30 would make us move to the right because positives are on the right side of 0. So 288 places to the left, 30 places to the right will bring us to -258. This is the value we get for part A. Go ahead and try part B and C on your own. Pause the video. When you're ready, press play and check your answers. The answers will appear in 5, 4, 3, 2, 1. Okay, so here are the solutions to B and C. If you agree, that's awesome. If you disagree, look at the steps shown and see if you could figure out where we differed. And even if you're using your calculator to help you with some computations, we want to show our thought process here and communicate on paper what we had our calculator do to demonstrate understanding or help us find the source of errors if something is going wrong. Well, that's going to wrap it up for this video. We're going to start another video for examples 5 through 10. Thanks for watching. And again, if you have any questions, bring them to school next week, and we'll clear everything up.